Okay students, as we were discussing in the previous lecture that the resistances can be added together in two forms. Either they are present in the series combination or they can be available in parallel combination. In the case of series combination, we see that we have several resistances R1, R2, R3 up to Rn. If we want to combine them in series, their net resistance or the total resistance is equal to the sum of all these R1 plus R2 and so on up to Rn. If we want to add them in parallel combination, this is like they are present in R1 in parallel with R2, parallel with R3 and so on, that the total combination or the equivalent resistance of the parallel combination can be found as 1 over R equivalent equal to 1 over R1 plus 1 over R2. So the resistances are not added as in the case of series resistance, rather they are added in their reciprocal forms, and after taking their LCM we get the total R equivalent of the parallel combination. In the case of series combination, the current remains the same, but in the case of parallel combination the voltage remains the same. Now as I see in this series combination, if there is a current I flowing, so in the start and at the end I will experience the same current, but the voltage will be divided. In the case of parallel combination, the voltage available at R1 is the same as voltage available at R2 and the voltage available at Rn, but the current coming from this point, it will be divided according to the resistance in first branch, in second branch and in nth branch. Now a very important law which relates all these quantities, electrical quantities, that is known as the Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points and inversely proportional to the resistance between them. Mathematically, this can be written as I is equal to V by R. Now I is the current, V is the voltage and R is the resistance. Now this is a physical appearance of a resistor. As we can see that it is a 4-lined resistor. The first line of any color represents the first digit of the resistance. The second line represents the second digit. The third line represents multiply by 10 to the power. It is the multiplier, number of zeros following the second digit. And the fourth line represents the percent tolerance, that how much tolerant this resistor can be. Now in the next slides we will see for its different combinations that how many combinations it can have. Now in the case of resistance calculation, one method is to find the resistance with the help of some device which is known as ohm meter, and physically by keeping it in hand we can find the resistance of any resistor with the help of this color coding table. So this is a standard color combination and we have to remember this, like black, brown, red, orange, yellow, green, blue, violet, gray and white. If it's the first band line, then it goes from 0 to 9. If it's the second band, then it goes from 0 to 9. But in the case of third band, it is actually the 10 to the power. So if I see that I have some combination of brown, black, so it will be 1, 0, multiply by, and if it is red, so multiply by 10 power 2. So it is 1000. So that is how we calculate. In the case of fourth line, if it is brown, plus minus 1% tolerance, if it is red, plus minus 2%. Normally they are in form of silver and gold. So silver is plus minus 10% and gold is plus minus 5%. If it has no color, no fourth line, then the tolerance will be plus minus 20%. Why we use resistors? So we use resistors because of three main purposes, either for the limitation of the current, or for the limiting of the voltage, or for the power dissipation. So if we want to limit the current, we use resistance. If we want to limit the voltage, we use the resistance. For the limiting of current, we will use resistances in parallel. For the limiting of voltage, we will use the resistance in series, and we can also use it for power dissipation. So that is all about the resistances. In the next lecture we will be discussing about capacitors. So thank you very much. See you next time.